Hi, you guys. We're not going to talk about any of that stuff. I have a lot I want to share, though. So years ago, I got to help start this company, which is, people think of it as like billionaires with their big swinging rockets, but what this really is a long-term vision for the future of humans. So in the best case scenario, Earth is kind of just going to melt into the sun, and this will all be over. But maybe we could intervene. And a project like this might take thousands of years, but it would still start with one small step. And what I learned from working on this is that occasionally you get some humans who escape the rat race and somehow figure out how to think on longer time horizons. You know, most people you know are just trying to pay rent and get their kids in college. I don't think Jeff's so worried about that stuff. And he's thinking about generations yet to come. And for me, it really changed how I think about the kinds of things that I work on. And I want to sort of share with you a little bit of that thought process, and then you can kick me out of town. So find yourself on this chart. This is like the history of humans here on Earth. Not very many of us. 160,000 years ago, you get the first Homo sapiens, and it's just thousands, hundreds of thousands, millions. And really not until the last 200 years did we hit that hockey stick growth curve and go from millions to billions almost overnight. And I think about everything in the world through this lens. This explains almost everything we are experiencing in the world today. What happened? Well, what happened is, along the way, we had to solve some of the hard technical problems that kept humans from thriving. How do you feed these people? Give them jobs, give them homes, eradicate the disease that's killing them off. 400 million people died of smallpox before vaccination was invented. That's more than all the people in North America, okay? So our job is to figure out, okay, how do we invent new technologies that help us solve a problem at a larger scale? That's how we got here. That's why you and I exist. And our job is to figure out, can we do that on this scale? We don't know if it's going to work. It's very scary. But I think we should try. So I want to talk a bit about what that looks like. We are all made of stars. That's not just song lyrics, like it's literally true. All of the cells in your body get the energy that made them from this star, our sun. And that's not just the solar power and the wind and photosynthesis and all that. It's also the coal and the oil and the gas. Actually, the uranium came from other stars. But basically, all the energy on Earth came from stars. And if you add up all the energy that a person on Earth gets, it adds up to about the same amount of energy, on average, as one toaster, running 24/7. You duct tape the button down, let it go. That's how much energy an average Earthling gets. Now, where I come from, we get 8 bonus toasters. Now, it's not because we're better looking or smarter. It's just that we got the best piece of land with the most extra energy. And so Americans are getting about 9 or 10 times as much energy as the average person on Earth. Canadians are usually right up there. People in this room, at least me, I'm probably in the 40, 50 toaster range, right? If you want to understand what's going on in the world, it almost all maps to energy. And I think it's very important to understand this because when you see the demand curve that people working, especially in like renewable energy, will show you, they show add a few percent a year. And that is a lie. The real demand for energy on this planet is about 10 toasters for every human on Earth. And right now, to get these averages, about 3 billion people live on less than 1 toaster. Right? We need to 10x global energy production on this planet, which I know sounds insane. Unfortunately, nobody else is telling you that. But guess what? We have done it before. In the last century, we 10x global energy production. And we did it the hard way, you guys. We did it by digging that shit out of the ground and burning it, right? This time, all we got to do is, make some solar panels and stuff, right? It's going to be a lot easier. So the problem with solar panels, well, there's two: clouds and nighttime. The relentless onslaught of night is fucking with our solar panels, and we don't know what to do about it. But check this out. We think they're saving the world. This orange line is the solar capacity in Germany that they've paid for and deployed. They're up to almost 60 gigawatts now. This is the number you'll read about in the press. They're very proud of it. Germans, this is the thing they're the most proud of right now. The blue line shows what's called capacity factor, how much energy is actually derived from those deployed panels. And you can see in the summertime, they get almost 18% of that number sometimes. Fun fact, in Germany, in the winter, the sun don't shine. So you're getting 2-3%. This is not going to save the world. This will not work. No matter how many solar panels you deploy, they don't make energy at nighttime. And we are lying to ourselves about this. And you can see it very clearly in Germany, where they decided to shut down their nuclear reactors that do run 24/7 and buy more gas from Russia in order to save the environment. I don't know how that adds up. German engineers were so smart when I was a kid. Now, I don't know. But check this out. If you take the same solar panels and you put them up in space, they'll get sun 24 hours a day. It looks like it's nighttime in space because we just have a bad angle on it. No, it's actually noon in space all the time. So they get 8 times as much energy, and you can beam it down to Earth using radio waves. This sounds like science fiction, I know, but it's all engineering we know how to do. It's actually not that hard. The power beaming stuff we solved, that's how your Starlink dishes work, talking to satellites, right? The only hard part is launch cost. And launch cost is plummeting. Ironically, launch cost has crashed. SpaceX got it down from $40,000 a kilogram in a space shuttle to about $1,500 a kilogram. Their target for Starship, their big rocket, is 10. In our lifetime, doing solar panels in space will become the lowest cost baseload energy anywhere on Earth. You don't need storage, and you don't need transmission lines. So what I work on, we call deep tech now. And I had a hard time at first trying to explain to people what that meant. So I started calling all the other stuff shallow tech. You've heard of shallow tech. You have it on your phone. These are great companies, some of them great products, but don't confuse it with technology. We think we live in a world full of technology. No, we live in a world full of software. We don't have a tech industry, we have a software industry. We don't have a venture capital industry, we have a software capital industry. What are we doing? We're making apps. And that's great, we need some apps, but we also need to go after the other things in the world. Software is eating the world, but the world can't eat software. Deep tech is all the other things. Cargo ships, people don't realize, have 2 gas tanks. You've probably never seen this black smoke coming out of a cargo ship because they have refined fuel in one gas tank. They use that till they get over the horizon where you can't see them. And then they switch to burning this nasty bunker oil that's like optimized for carbon emissions. I'm not kidding you guys. What if we made the cargo ships sail themselves across the ocean? Right? Like sailing's been working for centuries. You duct tape a Tesla to the front of this thing and it can drive itself. Like the tech's not that hard. Like why wouldn't we do that? This is a few % of global CO2 emissions is just getting Happy Meal toys from China to North America, right? And we could fix that, right? So we have a company working on that. In Silicon Valley, we have this kind of religion called scratch and itch. And scratch and itch basically means like, find some problem you have, your friends probably have the same problem. It's like budget market research, right? And I think that's okay. It's good to like do something you're interested in, learn to build a product, learn to ship it, support customers, all that, but think of that as practice, right? That's your practice company. Then take on a problem you don't have, a problem that 1 billion people have. It's harder, but that's where all the real action is. Here's an example. The most used material on Earth is cement. Except for the stuff that we burn, cement is the most used material. And it is very carbon intensive to make cement. And the weird thing is, it survives maybe 50 years and crumbles. We load it up with steel reinforcement, and in less than 50 years it'll crumble, which is hard to comprehend because of this thing. You recognize that building? It's made of unreinforced concrete with no steel in a seismic zone, and it's been there for 2,000 years. It's like the Romans built this amazing thing and then got drunk at the after party and just totally forgot how to make cement. Well, I found a team at MIT that just figured it out. We now know how the Romans made cement. We can now make cement that lasts virtually forever, use less of it, use less steel. It doesn't cost more. And the kicker, 20% less CO2. That's what's possible. It won't be hard. We can do it in any cement factory. We can upgrade the whole world. We've been recycling our whole lives, separating out our cardboard and plastic bottles, the cheapest crap on Earth, and it is not working. We are lying to ourselves. We've placated ourselves because we feel like we did our part, separating things out, but we're burning more gas to recycle this stuff than if we just made fresh plastic. I'm sad about that. I would like it to work. But problems like this fundamentally map to energy. If you had lots of clean, cheap energy, then you could do recycling. But we don't. So it's not working. Meanwhile, we haven't even started recycling the most expensive crap on Earth. So we got this team that figured out a modern chemistry that can separate the metals from all your electronics waste. Tens of billions of dollars a year of gold goes into electronics and then ends up in a gold mine we call landfill. Now we can get those metals back. Years ago, I got to help start this company called MakerBot. And the idea was the founders had never even seen a 3D printer. They were exotic, mythical machines that we had in labs. I think actually mine was the first 3D printer they ever saw that they didn't make. The MakerBot is like the reason you've heard of 3D printers. But what we thought was we're going to take these machines, wire them up to the buy now button, put them in data centers, and make stuff on demand. So you click buy now, we print your stuff and drop it in the mail. That didn't work. We're 15 years later, you don't buy anything from Amazon, it's 3D printed. And the reason it didn't work is 3D printers are slow. They're like 1 pixel printers. And the input materials are super expensive, high quality plastics. And you're competing with injection molding, which is like the cheapest way to make anything on Earth. So I found these guys who figured out how to 3D print with used coffee grounds. They literally get paid to haul this shit away from Starbucks, goes in the printer, which is a fast powder bed style printer, and they're printing not just coffee mugs, all kinds of durable goods, but they powder coat them or metalize them. You can't even tell they're made of coffee. They're making sinks and what else? This like wall art stuff and light fixtures. That's coffee, but coated in copper, light fixtures. They made this guitar. They can print with biomass, not just coffee, but seaweed, sawdust. They're making these things. Their customers don't even care that they're sequestering carbon or keeping biomass out of landfills. Their customers just care that the supply chain is reliable, because we can do this in the US, we can do it anywhere in the world, fully automated, no labor, and it's cheaper than injection molding in China, right? So when you hear about reshoring or trying to bring manufacturing back to regions or to new regions, this is the kind of thing we can do. We can use programmable manufacturing tools. So if you take all the software companies in the world combined, add them up, their total revenue is about $2 trillion a year, which sounds like a lot, except that global GDP is 100 trillion. 98% of what humans are doing is untouched by Silicon Valley. We aren't even trying. Anytime there's anything physical, we're just like, nope, go make some apps, right? We have overdone it on the Y Combinator playbook. We have overdone it on SaaS holes. We've already done all the easy shit, all right? It's time, and now is the time when we get to take everything we learned from making startups, from making Silicon Valley, we get to take everything we learned from our computers and all the super powerful tools we have now and go aim it at the biggest problems on Earth. If you close your eyes and think of the word pollution, you probably get a picture like this. These are smokestacks. We have them in power plants and factories, and what's going on is we're burning some shit, turning it into a bunch of what we literally think of as like toxic fumes and shoving it into the sky where we can try and forget about it. That's literally the definition of pollution. I found these guys who figured out a really efficient way to cryogenically freeze the exhaust. This is a mix of gases, and they separate out at different temperatures and liquefy. So they're getting nitrogen, oxygen, hydrogen, and CO2. They separate these gases out of the exhaust, pump it into trucks, and sell it. This is literally turning pollution into profit. Why wouldn't we do that? If you have an iPhone in your pocket, the cost of that thing is equivalent to the global median income. I'm not trying to make you feel bad. You should have an iPhone, and you should drive a Tesla, and you should help us waste a lot of money on all this cool new shit, because our job is to figure out which of it is good, and then figure out how do we take that to the rest of the world, right? The good stuff, not the shitty stuff. We've been doing it backwards lately. It's kind of embarrassing. Years ago, we started working on trying to solve infectious disease. And this is kind of the low-hanging fruit for humans. Millions of people die every year from disease that's just spreading they don't have any way of solving. Now, we don't have this problem here. We're good. But in the developing world, we still have tuberculosis, malaria, even polio tried to make a comeback, HIV. These things are taking millions of lives a year. So we started making computational models. These days, we would call them AIs. And the AIs let us take climate data, rainfall, travel of humans, all the things that affect the spread of a disease, and model the spread of the disease. So here we're doing it in Madagascar. If you go to Madagascar, make sure you go to the middle. This is for malaria. And in the dry season, malaria will go away almost completely. But because we have a model like this, we can test our interventions thousands of times in software before we do it in the real world. This is what's possible with AI. I don't give a shit about generative AI or chatting with robots. That is not what this technology is for. This is technology to help us make better decisions, right? In the first Ebola outbreak, 12,000 lives were lost. In the second Ebola outbreak, a couple years later, only 12 lives were lost. In part because using computational models like this, we were able to optimize the ring vaccination campaign, contain that disease before it spread. That's what would have been possible with COVID. But we weren't trying. These technologies are the best toolkit humans have ever had. We live in a renaissance. We have the most capability, the most superpowers. We understand the world better. We know how to solve a lot of these problems. We just need to get off our asses and do it. These technologies are the tools we need. It's time to start aiming them at things we actually care about to make the world a place that we want to live in. I think we've been telling ourselves the wrong stories. We tell ourselves a lot of scary stories. Hollywood picks up every new technology and turns it into the boogeyman. That's what they need. That's not what you need. We need positive, practical visions for how the future can be more awesome. So I'm trying to offer a few. Hopefully you guys have some too. I'm going to get off stage. Actually, I'm going to stay for a few questions. We're going to throw the mic around. You guys can beat me up. I promise I'm nicer than I seem. If you think I'm full of shit, please tell me. And then I'll be around all day. So if you have any interest, I would love to talk and hear about what you guys are working on. Thank you.
So first of all, turn around.
Oh,
turn around.
We're doing a selfie?
Well,
here?
We have to do one so I can tell
great.
people. Pablos has this thing where he like basically sends pictures of where he is in the world.
Yeah.
So I figured I'd cement this one.
It's my alibi.
It's literally called Pablos Stalkers. Okay, I'm going to throw this thing. We have time for 2 or 3 questions. You have to talk like this into the mic. Ready? Everybody watching? Nobody's on their phones. I'm throwing something.
Who has questions? Oh.
You're supposed to, that's it. So if you have a question, raise your hand and he will throw it to you. You can ask a question if you want. Raise your hand if you have a question. All right, throw it there.
Hello. So my question is, well, yeah. Let's see if I find a question within the statement. So I work with an accelerator program, and I understand what you mean that once there's a new app, people go crazy. It's like, how do we build an app? But how do we change the industry in the sense where we're not trying to get people to keep building apps, but we try to find a different way to influence change, you know? Because like, people see what comes from building an app. At the end of the day, everybody wants to make money. Yeah. So how do we change the industry to make people go towards like benefiting the world versus just building a new software that, as you said, it's like shallow tech, right?
Yeah. Well, look, I mean, I think these things do need to make money in order to actually sustain themselves, right? What I'm trying to show you is that everybody's fighting for the same 2% of the money. The other 98% of the money is in the things that we're ignoring with our apps. And so there's a lot of opportunity there. I think that's the new frontier for technology. And I think that, you know, most of the people who are, you know, a lot of entrepreneurs, they just want to build a product and build a company and do something successful. Most of them, I think, don't even care what they're doing, right? It's not like Mark Zuckerberg wants to use Facebook in the morning, you know? That's not like, does Travis ride around in an Uber? Probably not at this point. It was not what he was actually going for. So I think these are incredible founders, but we just need to aim them. I wish I had like Travis from Uber making nuclear reactors or any of the things I showed today. They'd probably be done by now, you know? We need our extraordinary entrepreneurs to aim at the things that are going to make a big difference. And I think that the basic arithmetic of adding up, you know, what's the scale of the problem in the world? What's the, you know, does the technology that we're bringing give us a 10x multiplier? You know, are self-sailing ships 10 times better? Well, they don't need fuel. That's probably a 10x less fuel cost. That's pretty good. So I think there's a, you know, when you start to look at the world through that lens and say, look, a startup isn't worth doing. It's not really venture. It's not really going to be meaningful if you're not bringing a new technology into the world. That's where you get the force multipliers. That's where you get the ability to make things better. And so I'm really looking to see our next generation of entrepreneurs take on finding, because scientific progress continued. Like, we have all kinds of amazing technologies just waiting to be deployed. So that's how I think about it. Yeah.
All right, who wants the mic next? We got time for a couple more. You got it? All right, go.
lots of great examples about technologies acting in the world and, solving problems. But it's also many technologies create problems as well. We know that. And what I'm thinking is, where's the structure, incentive, like social mechanisms for thinking ahead about externalities, side effects, and the complex interweave of any new technology?
I think it's important to think of these things in the context of the life cycle, right? Like, you wouldn't say that people are all idiots just because they're uneducated when they're babies, right? And I think even the language you use is wrong. We want to blame the technologies for our problems. I'm not saying these technologies will solve problems. I'm saying we can use these technologies to solve problems. And we can use these technologies to create problems. And so it's on us. It's entirely on us. There is no evil technology. There's only evil uses that come from people. And we need to take responsibility for that if we want to get better outcomes. So if we're not clear about what we care about and what our values are, then we're going to end up using these technologies for things that we're not happy with, or letting other people in society use them for things we're not happy with. And so I think that at the very beginning, it's very important to advance these things and figure out what's possible. Every time you ask a human to imagine the future of a technology, they will come up with the worst case scenario they can. Very few people are good at imagining the positive effects of a technology. And so I don't rely on the storytelling mechanism to make those judgments early. I think we build them, we try them, and we throw out what doesn't work. And that's my view.
Okay, one more quick question, and then we got to roll on. Can you throw that? You got the mic? Oh, great. It's already done. Thank you.
So given this incredible vision that you've shared, how would you flip the script? If we're missing 98% of the opportunity, what would you create? Yeah. Who would you convince? Which leaders, plural, which island would you settle on to build all of this? Yeah. Where would you start?
I mean, the truth is, I believe in pirates. Most of the big technology successes came from, they went through a life cycle. A lot of them you can map to scientific research, and you can map that back to governments supporting scientific research, which I think is very important. But there's a time when you have to do something in the world that's new for the first time. And it's very difficult to get that done with the established companies or established industries. And the reason is, what's great about software is, look, nobody loves software more than me, is the truth. But the reason software is powerful is that it allows us to try things for practically free. The marginal cost of trying a new thing in software is practically free. So we can have an idea, build it, ship it, scale it, sell it. You can do that 3 or 4 times in a lifetime as a founder. In every other industry, all the people working in the industry, by definition, were only there for one late stage of the life cycle. So they don't know what it's like to start an oil industry. They don't know what it's like to start a construction industry. They can't imagine that because that's not what their experience has been. We need all the software people to go build the things I'm talking about because we have to build them from scratch. And we have to do that because the Uber playbook is the winning playbook. In Silicon Valley, we don't go fix industries. We don't fix businesses. We get a technology and we use that to build a parallel industry or a parallel business and let the old one die. That's Uber, that's Airbnb, that's Facebook. This is what we're doing because it's faster and more successful than trying to fix and change the minds of the old guys. And so I think you look at these opportunities I'm describing, and there's hundreds more. You find one, and then you figure out as an entrepreneur, what's the fastest way to make this happen? And probably, trying to side with a Fortune 500 company is not going to be the answer. So anyway, thank you so much. Yeah.
Thank you, man.